Welcome, this is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post-Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
Well, this is going to continue us into the area of the question on hybrid, and we have Andrew, who's been previously introduced, and we have Lori, who's been previously introduced. Garfield, have you been previously introduced? I don't think so. Okay, well, he is Associate Chief of Strategic Technology at the U.S. Department of Homeland Security. He is responsible for developing the strategy and providing governance on the use of innovative and leading-edge technology across the CISA. And then Morgan, you've been previously introduced. So we'll get right to it. We have only two microphones up here, but I'll kind of pass them back and forth. If each of you would take about 5 minutes to discuss, kind of present your position on hybrid, and then we'll get into some questions.
Yeah, well, I'll keep my remarks brief because I had a chance to talk a little bit about hybrid during my earlier discussion. But I think, one of the things that always complicates these discussions about hybrid schemes is I think people come into these discussions with different ideas of what hybrid means. To some, as I said in my remarks, I was using hybrid to mean essentially using, two or more algorithms to kind of do the same purpose, do the same function within a scheme or protocol. But sometimes I think people look at hybrid as a more general term for, having, using PQC alongside, say, classical algorithms. And that's a much bigger topic that much bigger space than what I would call hybrid. That includes things like what Morgan referred to, I think, in his remarks as like the coexistence between, classical algorithms and PQC algorithms, which I think is going to be, play a major role in during the transition. So I think, when we have these discussions, it's important to be clear about what we mean, because the properties that you can achieve end up being quite nuanced, as well as the sort of costs, trade-offs, and benefits that you get from the different approaches.
Just adding to that, I think the fully agree that there's a definition problem around hybrid, but we also need to be looking at what is the motivation for deploying hybrid. And there could be different reasons why we want to deploy hybrid. It could be because we want to ultimately support a migration. It could be that hybrid is sort of the final destination, and the motivation will also drive what solutions we want to adopt, and will also ultimately inform some of the commercial viability around hybrid. Because, for example, one of the questions I would have is, if we're using hybrid as a migration mechanism, does that mean that we need to be factoring in two separate migration phases, and who's going to pay for them? So I think these are some of the things that need to be really specified and defined when we talk about hybrid. And what I'm seeing is that often hybrid, the word is sort of thrown around to mean basically anything with anything else, which doesn't really help. And we're seeing that often in some of the guidelines that are published, or in some of the discussions that people have. And it sort of leaves a sense of confusion rather than clarifying. So
Yeah, that kind of leads into where I want to start as far as the word being thrown around. I think that was the initial thought of when we were looking into this. Is I've been to several of these conferences and people started throwing around hybrid, and we've talked with our NSA and NIST counterparts, and it was kind of a taboo subject for a little bit. Gotta admit, Morgan, right? For a little bit, and. Oh, sorry, man. That's what happens when you let me go first. So there was there was a lot of stuff thrown around with that, and at first I was thinking, along with my team, is that no, we can't go that route. But then we started thinking in the DHS and CISA space, we have to deal a lot with the public, and we agree. Hey, go towards PQC. That's where you want to end up, and that's where you want to be. But there's a real life issue. We've got taxes, IRS, and stuff to deal with, and the public's not going to. Everybody's not going to migrate over to using PQC right away. So there has to be some kind of transition. And that's where we started looking into more of, is hybrid that transition period? And how much is it going to cost for us to implement that transition period? How much, what are the standards going to be? Are there standards coming out? Is anyone looking into this? The time, how long is it going to take for us to implement hybrid, to get to PQC, and so forth? And then the performance elements. Is it going to affect performance so that we can't file our taxes, which would be a good thing, right? But there's so many different agencies within that DHS space that we have to consider, and we've got our state, local, and tribal that we have to look at. We have to look at our critical infrastructure. How are we going to deal with that? Definition is really important. We looked at having classical and PQC work together, and maybe just having classical talk to classical and PQC talk to PQC. We looked at several different instances and how can we do that. We're not cryptographers at CISA, but we're gonna put some ideas out there, and we're gonna ask NSA and NIST to kind of vet those ideas and see if they can work. And then we looked at it in terms of cybersecurity. Is it going to bring a risk? Is it going to bring something that we can't, that's going to bring more problems to us? As you know, CISA's been pretty busy with all the attacks from our various adversaries. We don't want any more drama in our life. So we've got, if it's something that's going to bring more security issues, it's not something that we want to do. So we have to look at it from the costs, the time, the performance, and the cybersecurity risk. So that's where we're looking at it, and I guess that's why you guys kind of invited me to this panel.
Well, thank you for inviting me onto the panel or letting me hop along at the last minute. So for those of you who saw my talk earlier, I'm Morgan Stern, the senior subject matter expert at NSA Cybersecurity for quantum resistance, and I spoke about just there is some amount of uncertainty in NSA in the public of NSA's position on hybrid that I was hoping I clarified there, but I'll just quickly go over it again. First, we only have authority over national security systems, which puts me in a nice unique place that I laid out. They're very, very varied. So we have the NIPRNet, which is going to be a pretty similar environment to WebPKI. But at the same time, it has the advantage that the U.S. government owns all of it. Okay? There's a certain amount of trust in various routes because it is the U.S. government's very, very large network. But at the same time, we also have a variety of smaller networks. We have edge devices. We have many, many different form factors. So we do face a lot of these problems, a lot of different use cases. And in looking at that, we very much are striving for future interoperability and most importantly, really fast and secure transition. We have to get things done by the end of 2031 for the baseline, as I laid out in my talk. And, as you heard, there's the National Security Memo for 2035. And because of that, the fastest standards to deploy are the standards you are currently deploying. They are tweaks to the protection profiles you currently have out for devices and device families. And with that said, for the vast majority of protocols, the simplest is you need to make next to no change in the profile if you have added in your negotiation. We are now doing ML-Chem 1024. We are not doing P384 elliptic curve. Now, there are times where that's just not true. So in IPsec, as I said, you have issues with how much unencrypted data you're allowed to send. It'd be re-architecting a layer of the internet. You kind of don't want to do that. We're happy to use two different agreements there. That is the faster, more efficient, more secure way. It is more secure than re-architecting things and expecting people to do it right. So that generally, I think, covers our hybrid. When we put out guidance, when we put out our, say, RFCs on how CNSA compliant TLS is going to look, it is not going to have a hybrid, because that is not the thing that will be in our protection profiles later. It will be pure. Doesn't mean other people shouldn't use hybrid. We totally understand that. And we even can imagine in the future maybe we will have interoperability documents for dealing with other networks for other reasons. But the fast way to do it right now is with the standards you have, which is not going hybrid.
I would like to ask a question of the panelists with regard to hybrid as in the implementation of two algorithms simultaneously as opposed to any of the models where they're kept as separate. And in that instance, you have a standardization issue with regard to which algorithm went first and a number of other issues in that. Do you see any organizations developing standards that someone could follow if they so chose to go with a hybrid?
This on? Yeah. I mean, I think a lot of that's ultimately going to get driven by what the protocol or the application specifies, right? I think those kinds of details are going to have to be part of those specs. I do think that there'll be cases where one model would make more sense than the other, depending on what challenges you're facing. I think Morgan gave a nice example with things like Ike, where it's convenient to do them sort of separately in a non-composite mode because of the way that functions. I think within IETF we see like composite hybrid chems with things like TLS because that's a natural and fairly easy and straightforward way to do it. I don't necessarily think that there's going to be a one-size-fits-all approach, because I just think that's ultimately going to be driven by the protocol and driven by what problems you're trying to solve by choosing to implement hybrid.
So if you don't mind, I'm jumping on this. Andrew, I'm going to come back to you on one of those, because I think we talked about the critical infrastructure components and having that as far as a use case, and how do we, that was one of my I guess pushes, is the critical infrastructure components are not, that's our OT, and we've got to be really careful how we implement those standards within those components, because water is pretty important and electricity is pretty important and things like that. So I guess my thought on this is, when you're looking at the critical infrastructure components, are you more inclined to go towards hybrid? Are we more inclined to say, are we going to just use some kind of IT around those critical infrastructure components and then leave them in the classical mode, versus try to put the PQC algorithms on top of those?
Well, so I mean, first I want to come back to what I said during my remarks that NIST doesn't intend to make a sort of general recommendation for or against hybrid. We think that that's something that the different standards organizations, the different vendors and service providers need to look at their use case, look at their requirements, and decide if it makes sense. Because there certainly is, there's a cost in terms of complexity, in terms of additional code, in terms of some overhead that needs to be weighed against whatever is driving the decision to implement hybrid. I think sometimes there's a perception that hybrid makes it will make it easier to do transitions. And for the most part, at least at a technical level, I don't think that's usually the case. There's some exceptional cases like Ike where it's convenient to do hybrid, and that provides a simple path. But I think at a technical level, adding in hybrid is just essentially another cipher suite you need to be able to implement and negotiate. So I think where things like hybrid might help with this might speed up adoption isn't so much with making it easier from a technical perspective, but making it easier for a community to adopt it. Maybe they have regulatory requirements that requires the use of certain quantum vulnerable algorithms, or maybe they have, as was alluded to earlier, concerns about side channel attacks, and have done quite a bit of work within their community to validate a quantum vulnerable algorithm there. So again, I think it really comes back to understanding what problems you're trying to solve before you start looking at kind of what path to take and what solution to go after.
I'm just adding to that. I think it does need to be use case specific, and it does need to look at the problem that you're solving. But I also think we need to be careful that we don't sort of create a wild west of hybrid, and that there is some level of oversight, and that's where potentially the standards come in. And I know that in some cases the standards will delay things, and they take time, they take coordination. But then if we start looking at things like interoperability and backward compatibility, and these are some of the reasons why we'd be looking at hybrid in the first place. Actually, that standardization, it sort of offers the ability to ensure that you don't just end up with a huge amount of complexity, or you don't end up with deployments that aren't secure, or that aren't as secure as you might think they are. So I think there is a need for some level of oversight to ensure that we don't end up with just all sorts of weird and wonderful solutions that nobody has really checked.
Well, I would also like to suggest that some of the hybrid standardization is going to occur in industry standards bodies. I think that to the extent that financial services chooses hybrid, that X9 will probably take the lead in that, and that there are other organizational elements, the ITF and Insight, that also are good sources for potentially developing standards for their particular niches.
Yeah, sure. I guess to sort of point to one thing from my slides that I want to make sure on the audience who maybe are not all cryptographers. I want it to be clear that at an algorithmic level, you're not gaining any security, in NSA's view, from hybrid. I understand very much that there are people who are, less comfortable with the algorithms and might want to adopt it because they themselves are less comfortable, and that's very fine. But like the reason NSA for our users is saying to use MLChem is because it is the most evaluated key agreement ever. Like there have been lots of papers about Diffie-Hellman. I actually am, when I do a literature search, it is not clear you get as many from classic Diffie-Hellman as you get for learning with errors and the precedents for MLChem. This was, really an amazing accomplishment that Andy's team has done over the last 8 years. It really is an immensely secure algorithm that we have the utmost confidence in. And when folks say, yes, but maybe there will be implementations problems, I similarly worry on any combiner that this very much is what NSA is worried about. We know that NIAP is able to say, this is the thing that Andy's folks standardized, and that's what we want it to say. We are less confident in the ability for those same labs to say, right now, we could get comfortable with it over time, but it is a new thing to say, we are certain that we are combining these two things in a correct fashion, that the flaw is not there in this one library that is implementing this one combiner. And so you are adding new code when you are hybridizing, and you really do need new standards and new validation procedures.
One last, and then we'll go to question.
Okay, I just want to echo what Morgan's saying from the CISA perspective, that we are not saying that we're not going against NIST or NSA on any of these, that we're absolutely saying to go towards PQC. Our only consideration was about, how can we protect our critical infrastructure and have that backwards compatibility, that interoperability. That was our only consideration, but we are absolutely 100% behind the folks to go towards the using the PQC algorithms. Looks like we got the hook.
So, are we going to try any Q&A? Any questions?
Unfortunately, we have no time for Q&A anymore left.
Let's thank our panel then. Thank you.